all the numbers we can possibly think of use combination of 10 digits. Ayan yung tinatawag na decimal number system. Pero, alam nyo ba na meron pang ibang paraan ng pagbilang? So, ayan yung pag-aaralan natin ngayon. Different types of number system. Computer use different number system. Yung tinatawag na 2 digits or yung binary number system. Kung ang decimal number system ay base 10 or 0 to 9 combination, computer use binary number system. This computer use 2 digits number system or yung base 2. It's either 1 or 0. This system is called binary. Meron pa bang ibang types of number system? Meron pa. Pero, umpisahan nating pag-aralan yung decimal number system or yung 0 to 9 combination. All the numbers we can possibly think of use combination of 10 digits. Ano ba ang decimal number system or yung tinatawag nating base 10? Base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then, if we need to represent something higher than 9, we added digit to left and the next digit back to 0 and start over. So, each digit we add exponentially increase the amount of things we can represent. So, in this system, we add a new digit every 10 things. Each digit represent an increase to the power of 10. Ito yung tinatawag nating place value. Yung ones, tens, hundreds, thousands, and so on. Para mas maintindihan nyo, maglalagay ako ng 4-digit combination, then imumultiply natin to the power of 10. Let's say 5, 4, 3, 9. Each digit exponentially increase. 10 to the 0 power, 10 to the first power, 10 to the second power, then 10 to the third power. 9 multiply by 10 to the 0 power. So, alam naman natin na any number multiplied by 10 to the 0 power is number times 1. So, yung 10 to the 0 power is 1, yung value niya. So, 9 times 1 equals 9. Then, next digit, 3 multiply by 10 to the first power. So, 3 times 10 equals 30. Next, 4 times 10 to the second power. 4 times 100 equals 400. 5 times 10 to the third power is 5 times 1,000 equals 5,000. So, kung i-add natin itong lahat na ito, 5,000 plus 400 plus 30 plus 9 equals 5,439. Now, since elementary, napag-aralan na natin yan. What I'm doing is, ini-illustrate ko itong decimal number counting system because this is what exactly the manner of computing in binary system. Gaya ng sabi ko kanina, ang binary system ay base 2. So, para mas maintindihan natin, isa-isahin natin kung paano ba nagbibilang ang binary counting, no? Alam natin na ang computer, binabasa niya ang data or information, kino-compute niya through binary counting. Now, kung ang decimal counting ay may 10 symbols na 0 to 9, ang binary naman ay may 2 symbols. yung 1 or 0, like what I said before. And this is base 2. Kagaya sa decimal counting, each digit will exponentially increase but to the power of 2. Meaning, kung ang decimal ay may exponentially increase equivalent na 1, 10, 100, 1,000, 10,000, and so on. Ang binary ay 1, 2, 4, 8, 16, 32, 64, 128, and so on. Bakit? Kasi 2 to the power of 0 is equal to 1. Again, any number to the power of 0 is equal to 1. So, after that, 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is equal to 8. 2 to the power of 4 is equal to 16. 2 to the power of 5 is equal to 32. 2 to the 6th power is equal to 64. 2 to the 7th power is equal to 128, and so on. Now, let's go into details. For example, may binary combination tayo na 10101. Alamin natin kung ano ang decimal value niya. Beginning with the rightmost digit, these labels will help us to keep track of what each digit represents. In binary, the individual digit is called bit. If I'm going to use the term here, so bit 0 or digit 0, which is 1, is multiple of 2 to the power of 0. So, it's 1 times 1. Again, and again, and again. Any number to the power of 0 is 1. So, 1 times 2 to the power of 0 is 1 times 1. That's equal to 1. And bit 1 or digit 1, in this case, 0 multiple of 2 to the power of 1, so it's gonna be 0 times 2, and that is 0. Now, in bit 2, 1 times 2 to the power of 2 is 1 times 4, and that is equal to 4. Next, bit 3, 0 times 2 to the power of 3 is 0 times 8, and that is equal to 0. Digit 4 or bit 4, which is 1 multiple of 2 to the power of 4, is 1 times 16. It is equal to 16. Kung mapapansin nyo, parehas lang sila ng manner ng counting ng decimal number system. Ang kaibahan nga lang, kung ang decimal counting ay base 10, itong binary ay base 2. At kung mapapansin nyo rin, every bit or digit with the value of 0 is equal to 0. Because any multiplying by 0 makes the product equal to 0. Now, we are going to sum these digits. And i-disregard natin yung mga value na 0. So, 1 plus 4 plus 16 is equal to 21. So, ang decimal value nito ay 21. Now, to make not things be complicated, kung paano natin makukuha ang conversion of binary to decimal, if kabisado naman natin yung base 2 value, kukuhain lang natin yung mga digit na ang value ay 1, since lahat naman ng product multiplying by 0 is equal to 0. Lahat ng 0 ay ititreat natin as off, and lahat ng 1 is on. Yung on lang ang kukuhain natin ang base 2 value. So, let's try. Try naman natin panibagong binary digits. Let's try 110101. kunin natin yung mga digits na naka-on, and then kunin natin yung equivalent base 2 value niya, and i-add natin lahat. In these binary digits, it's gonna be 1 plus 4 plus 16 plus 32. Ang sum niya is equal to 53. Kung i-disregard mo yung lahat ng 0 at i-add mo naman ang lahat ng values na naka-on, which is lahat ng naka-1, ang sum niya is 53. And that is the decimal value of binary digits na 110101. Now, we already know how to get the value of binary to decimal. What if kung decimal to binary naman? Just a big tip to this number representation. It helps to be familiar to the power of 2, kagaya ng nasa table sa taas. The key is you are getting to deconstruct the number as the sum of powers of 2. So, ang easiest way, get the highest value of the power of 2 that is less than or equal to your decimal value. Since i-deconstruct natin, kailangan mas mababa or equal yung binary value. Now, the constructed value is gonna be 8 plus 5. Now, 5 is not a power of 2. The next highest is 4. 8 plus 4 is equal to 12. Now, the remaining is 1. And 1 is power of 2. Ganon din sa decimal to binary. Iti-treat natin si 1 as on and yung 0 as off. In this case, naka-on si 8, 4, and 1. So, it's gonna be 1, 1, 0, 1. Lahat ng power of 2 values na naka-on or nagamit is equal to 1. And lahat naman ng naka-off or yung mga hindi nagamit is 0. Let's try another example. Let's say 94. The highest base 2 value that is less than or equal to 94 is 64. And 94 minus 64 is equal to 30. And the next base 2 value could be 16, since 32 is higher than 30. So 30 minus 16 equals 14. Next, less than or equal to 14 is 8. 14 minus 8 is equal to 6. Next base 2 value is 4. So 6 minus 4 equals 2. Now, since 2 ay base 2 value, it should be on. No need to deconstruct pa to the power of 0 or kay 1. Ibig sabihin, hindi na natin gagamitin si power of 0 or si 1. So, naka-off na siya. So, it's gonna be 0. Now, lahat ng naka-on na values ay ang magiging 1 at ang lahat ng mga naka-off ay ang magiging 0. So, dapat ang maging value niya is 1, 0, 1, 1, 1, 1, 0. Ngayon, kung i-add mo lahat ng mga naka-on, dapat ang magiging value niya is 94. So, tama naman, 64 plus, 64 plus 16 plus 8 plus 4 plus 2 is equal to 94.